Yes. So in the last class, what we were discussing, we started the reliable protocol design. So means step by step, we start designing the reliable protocol. So we have considered the packet corruption so far, right? And first we just considered only the data packet can be corrupted, and then we also considered later in that next version that acknowledgement packets also can be corrupted. And so far we are considering when the packet is received, means successfully by the receiver, then the receiver is sending a acknowledgement. If the packet is not received correctly, means it's some of the bits are flipped, then it is sending a negative acknowledgement. So we are here. We were here actually. So RDT 2.1 means the reliable data transfer protocol version 2.1. So in which sender handles the garbled acknowledgement or negative acknowledgement, and similarly the receiver also we have designed. So I think we have left here that can we remove the negative acknowledgement from this, and we can just make a we can say is a knack free protocol can be designed in which there is no negative acknowledgement. So what is the means motivation for that to remove the negative acknowledgement? One thing is that protocol will become simple because just one you can say just one type of a control packet is there, that is acknowledgement, and there is no negative acknowledgement sort of packet is there. So that's the motivation behind that. So I think this exercise I gave to you people to try out. I don't know how many of you have tried out, but let us see that. Okay, what? So essentially means how to means take it up this problem. So if negative acknowledgement, so who is sending? The receiver is sending. So we'll just look at the first the receiver part. So this is our receiver for that. So now receiver, when it is sending the negative acknowledgement, when the packet is corrupted. Okay, the packet which is received by the receiver is corrupt packet, because then receiver don't have any idea that means what the, so this what this packet is there, so it wants this packet to be um, retransmit by the sender. So then it's sending the negative acknowledgement, right? Or then if the packet is received, it's not corrupted, and then it is sending a sequence with a out of order sequence, means right, this incorrect sequence packet, then it is sending a acknowledgement of the packet which is received, right? So in place of these two things, if simply the sender can send the acknowledgement, okay, acknowledgement of the uh, previously successfully received packet, right? That acknowledgement it can send, and that will be the indication to the sender that okay, the next packet is actually not received, because the receiver is confirming just the previously which packet is so far successfully received by the receiver. So if we look at the knack free version of this protocol, then you can see here these two events are converted into a single event, means the packet is received corrupted or it has a incorrect sequence number, means we call as a out of order packet, means the receiver was expecting the packet as an sequence number 1, but the packet comes at a with the sequence number 0. In which circumstance it can happen? Why this incorrect? In which circumstance incorrect sequence number packet can arrive at the receiver? Can anyone tell this?
When the I sir, when
Yes,
the acknowledge
I
sir, when
think
the
you're. Yeah. Yes, Igna.
Sir, I was telling when the acknowledgement of the packet 0 was corrupted, so the sender will retransmit.
So yes, the because it is waiting for the packet 1, but the acknowledgement of the packet 0, which was received before that, that acknowledgement might have corrupted, and due to that the sender has retransmit the packet, because then sender have no clue that whether the packet is successfully received or not, because of the acknowledgement received is corrupted. So that's why sender might have in send us that retransmit and retransmit the that packet. But actually the situation was like that, receiver was received that packet successfully, acknowledgement was corrupted, right? So that's why receiver is waiting for 1 and the sender is sending the sequence number 0. So in both the cases, if simply it sends the acknowledgement of the packet which is successfully received, means the acknowledgement which is a the packet which is successfully received is sequence number 0, and it is attaching the sequence number to the packet also. If you look at, go back to this here, in this case we are not attaching the sequence number to the acknowledgement packets, right? NAC, there is no sequence number is attached. ACK also, there is no sequence number is attached. So now with the NAC free, if we are making, then we are attaching the sequence number to the acknowledgement as well. So indicating that, okay, ACK 0 indicates to the sender that packet 0 is successfully received. So when the receiver is expecting, uh, say for example, sorry, sender is expecting here, okay, here we can see. So sender is waiting for send the packet numbers, packet sequence number 0 and waiting for the acknowledgement 0. So at this stage, if it is receiving a ACK with the sequence number 1, or the ACK packet is corrupted, then anyway it needs to resend the packet again, right? But if it is, even if it is received the acknowledgement with the incorrect sequence number, right? Expecting sequence number was 0, but the sequence number of ACK packet is received as 1. That indicates uh, that at a receiver, this packet 0 is may not be, either packet 0 is not successfully received, or so in case of the corrupted, then definitely the packet 0 is not successfully received, so it needs to send it again, right? So using just with the ACK number, if we attach, then the sender will come to know the exactly what packet has been successfully received and what is the next expected packet from the receiver side. So it will send it is 0 again. That may create a duplicate in case of if the packet was received by the receiver successfully earlier, then okay, duplicate packet can be easily distinguished with the help of this alternate sequence number. So we can make this protocol as a NAC free. So using the acknowledgement, and so instead of the NAC, the receiver sends acknowledgement for the last packet received. So last packet received means, so acknowledgements also, now we are adding the sequence number. So acknowledgement have been augmented with the sequence number. So that, and the rest of the things will be same.
Sir, instead of adding a sequence number to acknowledgements, we could
Uh,
have also added a timer at the sender end that if I do not receive an act in within, let's say,
no,
30
no.
seconds,
So
I'll
no,
resend.
no. See, yeah, that's so. But here, we our assumption so far is that the packet cannot be lost actually, right? Underlying channel is, we are not losing the packet. Packet may be delayed. That's not a problem. But ultimately, packet will be received. Means it's no loss cannot happen. So that timer is basically not required. If the packet will come, sometime packet will come, and when the packet will come, then only we will able to send the next packet only,
Okay.
right? So now we are going to the timer actually. So now we say that, okay, the channel can generate the errors in the packet, means packet can be corrupted, as well as the packet can be lost also. Packet can be uh, means it may happen that a packet is lost somewhere in the between the sender and the receiver. So then you see the scenario, what will happen. Suppose sender have sent the packet and receiver has not received that packet. So now because receiver has not received the packet and the receiver means now will not, definitely there will be no acknowledgement will be generated from the receiver, and sender is means waiting for the acknowledgement. Without getting acknowledgement, it cannot move to the next state. So it means it's a deadlock situation, means neither sender nor receiver will able to move from their current state. So to take out the sender and receiver from the deadlock situation, deadlock state, we need a timer. Means after sending the packet, sender wait for some time for the acknowledgement. If we were not considering the losses, then this timer was not required, because definitely whatever packet I have sent, it will at some point of time it will reach to the receiver, and then the receiver response also will come, because that also cannot be lost. So with the assumption that okay, the underlying channel is not losing the packet, then I don't require the timers. But if the underlying channel can lose the packets, then the timer is required. So means now what changes we need to make it to incorporate the packet losses. Now packet losses, when I'm saying, then okay, the packet, both types of packet, data packet as well as acknowledgement packets, right? And right now we already converted our protocol into the only the ACK based protocol. No NACs are there. So we say ACKs also can lost, or the data packet also can lost. Now so we need what checksum anyway we are using for detecting the errors in the packet. Sequence number we already introduced, and ACKs, and the retransmission will help to. So the retransmissions we are using, because in case of packet is received corrupted, then we were retransmitting in RDT 2.1. Now what else we require? As I said that okay, that is the timer will be required, right? So now sender will wait for a reasonable time. Now this reasonable amount of time is what? Okay, right now we are not means going to that on what basis. So when we will discuss a specific protocol, then with respect to that protocol, we'll say that okay, how it is calculating or estimating this retransmission timeout, means how long a sender should wait before retransmitting the packet. So that some time right now you assume that okay, there is some method using that it will calculate that amount of time. So it will retransmit if no acknowledgement is received in this time, and if packet is, so now in this situation, two possibilities are there. If the suppose packet, either it is a data packet or acknowledgement packet, is just delayed and not lost, then what happen? My timer expires, then the packet will be the timer expires, then the sender will retransmit the packet, right? And that retransmission can create the duplicate. But duplicate, we know that how to handle the duplicate with the sequence number. We introduce the sequence number. Using the sequence number, duplicate packets can be easily handled, right? So duplicacy is not a problem, means duplicate packet easily can be discarded, because that could have happened during when we consider the packet corruption, right? So the receiver means when we consider the acknowledgement corruption, so the receiver must specify the sequence number of packet being ACKed. So see, the acknowledgement also involves or include the sequence number that will indicate to the sender which packet is acknowledged. And the timer, which is we will consider that is a countdown timer. So after sending the packet, a countdown timer will start, and when the timer expires, then the sender will consider to retransmit it. So now just look at this, the sender and the receiver version of FSM version of for this loss based, including the packet loss. So I think it is quite simple now. So as as in earlier versions of this protocol, we have discussed that this is the initial state, and sender is waiting for the packet 0 to come from the application, receive the data. It will make the packet and add the checksum and send the packet. And the new thing is that this is starting the timer. Okay, so a countdown timer is started, and then it move from the state 0 to wait state, means here is waiting for the acknowledgement 0 now. Now at this state, if you just look at the receiver, so when the receiver will receive this packet, so initially receiver is waiting for 0 from the below. So once it is received, then it packet is not corrupted and has the sequence number 0, means the expected sequence number only. Then it will extract the packet, deliver the data to the upper layer and send the acknowledgement 0. Okay, and now this acknowledgement 0 is here, maybe it can be received corrupted. So in case of the corrupted, then it will not do anything, right? So it is a corrupted acknowledgement is received, or the incorrect sequence number acknowledgement is received. Then it is not doing anything, no action is taken. Why? Because the timer is already running, right? So when the timeout occurs and the acknowledgement is not received, correct acknowledgement is not received, then it will send the packet again and then start the timer again. So if the packet is successfully received, like this acknowledgement packet is successfully received and with the correct sequence number, then it will stop the timer and it will enter into the state that it will now ready to send the next packet. Okay, so here it will then it will wait for the call from the above for the next sequence number packet, means next set of data, and that data it will using that data it will create a packet with the sequence number 1, because now the next sequence number it is to be sent is 1, and then start the timer for that. And here also again this the same situation can occur, either the packet is received corrupted or its acknowledgement is not the expected acknowledgement number. Then it will not do anything, no action is there, wait for the timeout, and the packet will be retransmitted again and the timer will be started. If before the timer expire, if the correct sequence number and packet is correctly received, then it will stop the timer and the move to the next state. Now you see that what is this actually, what is this state, means this you can say event which is occurring here at a state 0 also and the state 1 when wait is. What causes this event to occur?
Sir, if there is a duplicate like packet transmission, then the duplicate acknowledgement will also come. So this.
So duplicate acknowledgement also can arrive. So when the duplicate acknowledgement arriving, then it needs to, the sender needs to discard immediately. Okay, so because there's no, so here if it is, so in this state, suppose, so this state is what? This state is when the sender is not expecting anything from the receiver. Sender is just waiting for the data which is coming from the application at the same host, right? So because there may be a delay from the application side also, in that case maybe immediately data packet is not sent by the sender, it is waiting for that. That's why it's a wait state is there. But at this stage, if the duplicate ACK which is coming from the receiver side, so that needs to be discarded actually. So discard means no action will be taken, only the event is occurring receive packet. So that can occur at a both state in the at the sender side, right? So receiver side we don't require any timer. right? So the timer will be required at the sender side only. So sender will send the packet and wait for, let us say, some time before receiving the acknowledgement. So if within that time period, if he's receiving the acknowledgement, then it's fine. Otherwise, it will retransmit the packet, right? So this is the way how we can incorporate the losses also in that. Okay. So
Excuse me, sir.
yes.
Sir, I have one question. Like, if when the sender is waiting for ACK0, if a corrupted packet occurs, sir, wouldn't it be more efficient if the sender, when corrupted packet occurs, it immediately sends the packet again and starts the timer instead of waiting for the timeout?
Yes, that maybe that can be done. That will means that will improve the, you can say it will reduce the time, or you can say improve the protocol as such, because uh, so yeah, that is possible. That's possible. It can be done, but means we so optimization, this kind of optimization can be done. Just I'm just thinking that, okay, is there any so if it retransmit here itself before timer occurs, means on the receiving of corrupted packet.
Sir, so
Okay.
like, isn't it possible that the corrupted packet, like the corrupted packet was an acknowledgement from for some previous packet, and the sender might still receive a correct acknowledgement before the.
Actually the original acknowledgement is, let us say, on the way,
Yes, sir. Right.
and that may arrive before the timeout, and then you unnecessarily retransmitted actually. So means both possibilities are there. Means in, if it is really that acknowledgement which is it is waiting, and that acknowledgement is corrupted, sorry, uh, that packet was, let us say, the packet sent by zero packet sequence number zero packet sent by the sender, and that packet was corrupted, then this retransmission is fine. Quick early retransmission you can do before timeout occur. But as someone has mentioned, sorry, I'm not able to see the name, so fine. So in that case, it may be possible that, okay, the acknowledgement, correct acknowledgement is on the way, and before that you have retransmitted the packet. That's unnecessary retransmission actually. So means you may sometime you may have a means you get some improvement, but sometime the possibility of unnecessary retransmission also will be there. So it's a kind of a trade-off, right?
Okay, sir, got it. Thank you.
Yeah. Okay. So now we just look at that, because according to means the, so reliability means feature, that one of the reliability feature that is in any reliable protocol must have is that each and every packet which is delivered by the which is sent by the sender, that should be received by the receiver successfully. Means that's a one, you can say, task of one of the component of the reliability. Okay, there are other components are also there, like flow control and congestion control. We'll come later, but the basic aspect of the reliability is that whatever I am sending, that is received at the receiver successfully, without, and if in case if it is not received, then I have a mechanism through which I can retransmit it until it is not received successfully. So we have considered all cases like packet corruption, either side packet corruption, or the packet losses either side, and then our protocol is perfectly working, right? In any, so in using that, we can successfully transfer the packets from the sender to receiver without any error or without any gap. So now let's look at that, how it is, this RDT 3.0 is working. So this is the operation with no loss. So let us say sender send the packet 0, receive the packet, and send the acknowledgement for 0, then send the packet 1. So everything is means perfectly working, no loss, no error. So that means it is, so this way it will work. Now look at this packet loss scenario. So suppose packet 1 is sent, and then that is lost somewhere in between the sender and receiver. Then what happened? The timer is running, and once the timeout occur, then the packet will be retransmitted, and then again. So you can see that after packet 0, packet 1 is received, then again 0 is received, and the protocol is working perfectly. Now you see that ACK loss scenario. Okay, so you can see here this acknowledgement is lost. Now acknowledgement lost, then because until the acknowledgement is not received, the sender will not consider this packet 1 has been successfully received, right? So its timer is running, and if acknowledgement is not received before the timeout occurs, so that then it will retransmit the packet 1 for which the acknowledgement was lost again. Now, in this case, what happened? Because this acknowledgement was lost, actually receiver have successfully received the packet, right? So that's why it is when this retransmitted packet from the sender will be a duplicate packet at receiver, right? Because packet 1 was already received, and now the receiver was waiting for the packet 0, not the packet 1, right? Because our sequence numbers are going 0, 1, 0, 1 in alternate fashion. So because in a stop and wait, just two sequence numbers are sufficient to successfully uniquely detect a packet, right? Okay, so here duplicate, so no problem, duplicate can be discarded by the transport this protocol, and only the one copy of the packet will be that is already delivered to the application layer. So it will just send the ACK. So it is sending ACK1 because ACK1 means it's saying that AC packet 1 is successfully received. So after receiving this ACK1, then the receiver sender will able to send the next packet. Because here if it is not sending the ACK1, then again it's a deadlock actually. Because until the sender is not receiving the acknowledgement, sender cannot move to the next packet sending. So that's why after receiving the duplicate packet, it needs to resend the acknowledgement. Because duplicate packet, why the sender has sent the duplicate packet? Because it might be the acknowledgement was not received by the receiver successfully, sorry, by the sender. So that's why it needs to resend it. Otherwise, the duplicate packet will be coming, and the protocol will be in the deadlock state. Means it's not moving further if this acknowledgement is not resending after receiving every duplicate packet. So we need to send it. Okay, now another situation which can occur in this is the premature timeout. So you see here, packet 0 is sent and acknowledgement 0 has been received. Then packet 1 is sent and its acknowledgement have been transmitted by the receiver. But let us say by the time before the acknowledgement receives, the timeout for the packet 1 is occur. Timeout occur at the sender. So timeout occur means once the timeout occur, then sender will retransmit the packet. So in that case also a duplicate packet will be received. So actually acknowledgement is on the way, right? So this duplicate packet is not a problem because receiver knows that okay, after sequence number 1, my next expected sequence number is a 0. So it can easily discard this sequence number packet. There's a duplicate, it can identify it's a duplicate packet and send the acknowledgement. ACK1 of the means the packet for which the acknowledgement for the packet which is successfully received. So it's sending the again. And now after receiving this acknowledgement, yeah, ACK1 it will send it, and that ACK1 will be received by the. Meanwhile, you can see here. So this packet 1 was retransmitted after timeout occurs, and after that it sent the and then after sending this packet 1, it receives the acknowledgement. Acknowledgement 1, right? So actually means here the sender will not able to figure out that this acknowledgement is the old acknowledgement or it's the acknowledgement of the just now I have sent the packet. Means this packet acknowledgement or original packet acknowledgement or duplicate packet acknowledgement. And that need not to be means it is not required that sender should distinguish between these two. As far as the sender is receiving the acknowledgement of the packet 1, that is okay for the sender to go for the next packet to send, right? So that's why immediately after receiving the acknowledgement, it is sending the packet 0 here, right? Now this packet 0, receiver will receive in the means correct order, because receiver have received 0, then 1, then again 1, so that is a duplicate, and then again 0. So 0, 1, 0. It was expecting 0 only, 0 is received, and 0 acknowledgement have been transmitted from here. So this acknowledgement, which duplicate packet acknowledgement also will go, right? So that acknowledgement will it create any problem here at a sender
No, sir,
side?
it is being handled already.
Yeah. So that will not create a problem. But the premature timeout means create the unnecessary retransmissions. So that's why it's a very crucial for any protocol that, okay, how are you deciding the timer value? How long you should wait for the packet, for the acknowledgement of the packet after sending the packet, means how long you should wait. So how to decide that? Means roughly if I say that, okay, it should be equal to the RTT, means once you send the packet and 1 RTT at least you wait, but you know that, okay, there are the delays are there, queuing delay is there, that can be invariable, depends upon the congestion level of the network. So if everything is fine, then your acknowledgement should come within a 1 RTT. You send the packet and in a 1 RTT time, you will receive the acknowledgement. But this can be delayed due to the network congestion, if the network is congested, and which delay component is involved in that, that is a queuing delay. So due to that means your delay, or you can say your RTT is invariable in that case. It is not constant, even the between the fixed sender and the receiver, and that creates the problem, right? So we'll see that how in TCP we estimate this timeout value, and it is certainly it cannot be fixed like, okay, it's some 10 seconds or 5 seconds or some, that cannot be. It has to be changed because my network state is changing, so this also needs to be changed over the period of time. So this we will timeout estimation we will discuss in when we'll discuss the protocol, TCP protocol, that is based on that. Here in generic we are just talking about the protocols design. Okay, so now,
Excuse me, sir.
yeah,
I have a question in the previous slide. So can you go back?
yes, tell me.
Sir, when the sender receives the acknowledgement for the duplicate packet 1, won't it send the think that the packet 0 was not packet 1 was packet 0 was not received, and it will retransmit packet 0?
Yes, packet 0 it can
Sir,
retransmit
so
here.
it will, sir, so this will keep going on, and will send a packet 2 times instead of 1. Like,
No, but how long it will go means that will be again depends upon how these acknowledgements are coming, and will it be? I don't
yes, sir,
think that it will be.
yes, sir, it might follow the same order that we saw right now, and we have to transmit each packet twice. We'll keep on transmitting each packet twice.
Sir, I
Yeah.
don't think it will happen, sir, because when the duplicate acknowledgement 1 is received, we are not immediately retransmitting, but waiting for the timeout.
Which one?
Right.
So yes, right. The packet 0, because when it sent the packet 0, so it will now here it will start the timer, right? And packet 0 timer is running. Let us say packet 0 timer is up to here. Now before that, if it is, so this timer is for packet 0. Let me write here so more clarity. And then in between it is getting the acknowledgement 1. So acknowledgement 1 indicates that, okay, means that will indicate to the sender that, okay, packet 1 is received but 0 is not received, right? So means here, but here it will not take a call to retransmit. The same case I think that someone has asked that why it is. So here in this case, even if it is received the acknowledgement in out of order acknowledgement, so it will not retransmit the packet immediately. It will wait for the timer, right?
Yes, sir.
So
Yes, sir.
and then so you see that before the timer, if now this ACK 0 will come, now ACK 0 come, then it will cancel the timer, and after receiving this ACK 0, then it will send the packet 1 here. and start the timer again. Start the timer again. So it will not be continue, means okay, after one duplicate packet, then after that subsequent packet will not be duplicated.
Oh, so.
Right? Can we move to the next slide?
Oh, so.
Yes, sir.
Yeah.
So what if the duplicate packet which we are sending that corrupts? Like we are matching the duplicate packet with the ACK of the initially sent packet, right? But what if the duplicate packet which we sent that corrupts?
Duplicate packet which we send, okay, that corrupt. So corrupt means if it is corrupted packet received by the receiver, then receiver will again send the what acknowledgement, because so you are saying this packet, right? This packet is corrupted.
Oh, yes,
So
sir.
if so this packet is corrupted, then what receiver is supposed to do? Receiver have already received the packet number 1. So now receiver will send that ACK1. In that case also receiver will, whether this packet is corrupted or it is duplicate, it will send the ACK1. You see this state diagram. So if receiver receive a corrupted packet and out of order sequence number, sorry, this is a correct sequence number, no? Sequence, okay, it was waiting for 1. So you see, it received a different sequence number, incorrect sequence number packet, or it is corrupted. In both the cases, it is sending what? Acknowledgement for the previously received, successfully received packet.
Oh, okay, sir. Got it.
Right? So this will take care of that. So in this case also, yeah, here. So if even either this packet is corrupted, or if it is not corrupted, then it's a means wrong sequence number, because sequence number, expected sequence number is 0 here by the receiver. So in both the cases, it will send the acknowledgement of the packet which is successfully received so far. So it will resend the acknowledgement ACK1.
Sir, if the acknowledgement 1 of the duplicate packet is
Mhm.
received after the acknowledgement 0, then it might treat it as the acknowledgement of the next packet that it is going to send.
Okay, that case we need to see how it will. So you are saying this acknowledgement, let me change the color of, so it will be visible to you. So you are saying that, okay, this acknowledgement, right?
Yes, sir.
This acknowledgement is received when?
Like ACK0 is received. After that, the sender sends another packet 1. And then after that,
No,
the
no, no,
ACK1 is.
so this is ACK1, na?
Yes. So this is
Yeah,
received
this
after ACK0.
received after ACK0 means something like this.
Yes.
Na?
Yeah,
Hmm.
and as soon as
So,
the sender receives ACK0, it might have sent another packet 1, right?
so let us see that. So you are saying this ACK1 is appearing somewhere here at this time.
Yes.
Let's do something. एक बार इसको थोड़ा सा clean करते हैं. Let's clean this. Okay. So now I think it is better. So I will use the same color pen. So this ACK you are saying, okay, it is coming sometime here. Okay, so what is the situation at the sender? Sender situation is like sender has sent the packet 0. So the sender is wait, packet 0 it has sent,
It has
and
also received acknowledgement 0.
just wait, sender send the packet, and timer, I'm just saying that timer is running for what? Timer for 0. This
Okay.
timer is running.
Hmm.
Now we need to means now let us say you want that, okay, this timer is before the timer expire, this ACK1 is received.
No, so ACK0 is received. After receiving ACK0, it sends a packet 1, and then this ACK1 is received.
Acha, will this situation occur or not? That I just want to, because it's a hypothetical. So we'll see that, okay, whether it will actually we'll go one by one, then will it occur or not? So I want to just checking that. So you are saying this ACK0 is received.
Yes, sir.
and packet 0. So packet 0 sent, and then the corresponding ACK1 is received. Okay,
Yeah.
and this ACK is actually delayed. Okay, still fine. And after receiving the ACK 0, and naturally the timer will be stopped, because once you receive the ACK 0, then it will send the packet 1.
Yes. So
Right?
while packet 1 is in transit, if it receives the ACK1 of the previous packet.
So packet 1, and maybe, okay, so you are saying the packet 1 is maybe in transit.
Yes.
And in transit and receiving the ACK1. Okay. So then we mean then in that case the sender will assume that packet 1 is successfully received. So here sender can initiate the packet 0.
But this might be a problem now, because the packet 1 might drop.
Sir, it will only occur when the route of acknowledgement 0 is different from that of acknowledgement 1 packet. So it will depend on the routing algorithm.
No. Okay, no. So route can be different, because that even between the sender and the receiver, we don't know that, okay, maybe packet 1 is following the route 1 and packet 2 may be following the route 2, because that is not in the control of transport layer. That possibility is there.
Okay, sir.
So this possibility is there. You assume a situation in which that, okay, suppose some of the packets have been exchanged between sender and receiver, and then maybe something has happened, a intermediate router fails or something. So the routing system provided a new route, and now subsequent packets are following that route. So that possibility is there. Just to look at that, okay, whether
then there is a possibility that timer for ACK1 is completed. So we may neglect that ACK1 which is coming later.
No, just a moment. But no, the wrong ACK can come. The only thing is that we need to see the state by state. We need to just that I was trying to do that only, whether the situation will actually occur or not. Okay, because we need to go step by step for both sides. Then only we can say that, okay, what will happen. So okay, just give me a 1 minute time. So okay, time for 0 will be expire, and sorry, not expire. The timer for the packet 0 will be terminated, because ACK0 is received. Fine. After receiving the ACK0, then the sender can start the packet 1, and packet 1 timer is now running. So timer for packet 1 is running. Okay. Acha. Now saying that, okay, let's say by that, okay, it is on the way, let us say packet, and this delayed acknowledgement is coming now. This delayed acknowledgement is coming now, even because delayed acknowledgement came here also. Okay, but yeah, that situation was slightly different. So now this sender may assume that, okay, this packet 1 is successfully received. So the packet 1 timer also, it will stop, and it will send the packet 0. But what will happen at the receiver? Receiver, what it will do, what is the situation? So after receiving this packet 1, receiver have received the packet 0. Okay, and then it is waiting for packet 1. Then it is waiting for packet 1, and you say that, okay, packet 1 is not, let us say, received. Packet 1 might be dropped. Then what the receiver will receive packet 0. Anna? This packet it will receive. So that is out of order packet, means it's not a correct sequence packet, because receiver is waiting for 1 but receiving 0. So 0 means it will, what acknowledgement it will send? It will send acknowledgement
0.
0. So 0 acknowledgement it will send. तो क्या होगा? 0 acknowledgement it will send, and ACK1 AC तो okay ठीक है. So packet 0, and so this packet is not received, and this packet after that packet 0, so 0 it will consider as a correct currently received packet, and it will send the ACK 0. Acha.
Sir, is there a way to distinguish an acknowledgement for old packet one from new packet one? If that is
Mhm.
possible, then we can, like, this situation can be resolved.
No, that is not possible. Only the sequence number is the only means that indicates that okay, which packet sequence number is there. So that's why means it is done like that, because so after receiving the packet 0 only, then I am sending the packet 1. Once sender is confirmed that yes, this packet is received, then only it is sending the next packet. Otherwise, until this acknowledgement is not correct acknowledgement is not received, or the expected acknowledgement is not received, until that it will retransmit that packet only. But still I am not very sure that okay, this situation will occur, because we need to, I think, do it in a
Sir, in this case, can we check the time at which the packet one acknowledgement for packet one was sent? Because this acknowledgement was sent before we even transmitted the new packet. So we can,
no.
if
So
that's possible.
yes, so these all things can be done, that's fine, but that definitely means technically it is possible, but okay, how it means they will make my protocol very complicated, no doubt. Means multiple timers needs to be, and then the means the timestamp with respect to that host needs to be attached, right? So that needs to be read. So it will make the protocol complicated. Only thing is that okay, means the feasibility of this, and what it will feasibility of this you can say event, we need to see that. So we'll do one thing, I think, we need to see step by step, we need to see that okay, how that situation will occur, and then what problem will be there. Now at present it looks like that okay, it will be wrongly interpret that packet, means uh, the sender will consider this acknowledgement will be treated wrongly, and that will may create a problem. But I think you need to, once again we need to do it. So you can also try out anyway. You understood that okay, what scenario we are going to test it, verify with respect to this protocol, and let us take this topic on the discussion forum, right? So we will answer. So I'm just 2-3 slides I will cover now. Okay, so uh, now let us look at this the performance of this protocol. Means so for the performance means basically we are interested that how much utilization is there. So take this example, this first packet, let us say time t0 it is transmitted, and so it takes L by R of time to transmit time. Transmit L is the length of the packet, R is the rate. So let us say you have a 1 Mbps link, and 1 megabit packet size is there. So it will take 1 second over that to transmit over the 1 Mbps link, right? Megabits per second. 1 megabit is a packet size, L equals to 1 megabit, and rate is equal to 1 Mbps. Okay, small b means bit, capital B means byte. So in this case, 1 second it will take my t is equal to 1 second, and then there is a means after that the receiving this last bit of this packet, then the receiver will send the acknowledgement. Acknowledgement, you might have observed, you might have question in your mind that why for acknowledgement you have not considered this transmission time, because acknowledgement packets are smaller packets, so they take a very less time, negligible transmit time. So if it is a few bytes acknowledgement packet is there, or a 1 Mbps link, maybe it will take a few milliseconds. Okay, so that means it's negligible. So that's why it is not considered. So we'll say this is a RTT plus L by R time. So so in RTT plus L by R of time, L by R of time is used for the actual transmit the packets. Remaining time you can say is a kind of a overhead in that case. So utilization, if I just look at, if a 1 Gbps link is there, 15 millisecond is end-to-end propagation delay. This is 15 millisecond from here to here, and 1 kilobyte packet is there. packet size L equals to 1 kilobyte. So then my utilization will be this. So you can see it's a very low utilization. So if we go with this in this form, like stop and wait kind of thing, send the packet, wait for the acknowledgement received, then send the next packet. So then you see, and you can see from here also this much of time is wasted. Actually, nothing is happening. No data transmission is there. So for in each transmission, you can say the RTT amount of time is just wasted, means no transmission is going on. So the better way is that, okay, we should make this protocol as a pipeline protocol. Means we can have a more than one packet or the multiple packets in flight, which yet to be acknowledged. So not just one packet. So in the stop and wait, what is it? Always I have one outstanding packet whose acknowledgement is yet to be received. But if in case of that, if you go for a more than one packet, so that is called as a pipeline scenario. So for that, definitely we need to modify our protocol also. But let us see that, okay, how this mechanism is going to improve my throughput or performance of the protocol. So let's take one example. Let us say I say that, okay, my I can send the 3 packets without waiting for the acknowledgement, okay, at a time. So one packet, second packet, third, all 3 packets I send one after the other, and after three packets, let us say I will wait for the acknowledgement first, and then only I will send the next set of 3 packets. So in this case, what happened in a RTT plus L by R of time, I am able to utilize 3 L by R time, 1 L by R, 2 L by R, 3 L by R of time. So this is increasing the utilization by a factor of 3. So like that, if I increase the number of packets, in-flight packets, if I increase, then my the utilization also is going to be increasing with that factor, right? So in place of 3, if I say 7, then maybe 7 times my utilization will increase. But now the question is how long I can go and what are the implication of that? Because now if I say that, okay, 3 packets I can send, then I cannot survive with the just 2 sequence numbers, right? 0 send, receive acknowledgement, 1 send, receive acknowledgement, 0 send. So I cannot go with just 2 sequence number. So here in this case, let us say I need all these 3 packets to be uniquely identified. So 0, 1 and 2, 3 sequence number I have to use, right? So now after that I may receive, let us say, acknowledgement 0, then so it is something like this kind of a protocol. So in this way it will work. So my sequence number is, let us say, going 0, 1, 2, 3-bit yeah, if it is a 3-bit sequence number, 3-bit sequence number is there, right? So in 3 or 2-bit sequence number if I take, so 2-bit means I have combination 0, 0, 0, 1, 1, 0, 1, 1, 4 sequence. So in place of 3, let us say I have 4. So I say 0, 1, 2, 3. Then again 0, 1, 2, 3. This way my packet sequence number goes, right? And I say that, okay, at a time I can send 4 packets without waiting for the acknowledgement. So 4 packets I send, and then after that means before sending the next packet, I should get at least 1 acknowledgement. So if the 0th packet acknowledgement once I receive, then what I will do, I will slide this window to here. Okay, so this packet acknowledgement received, then okay, now this is confirmed that this packet is received. Now 1, 2, 3 acknowledgement is still pending, and this packet I can send. This is the next packet which I can send it. And once I receive the first packet acknowledgement, then I can shift my window to up to here. So at a time, I can have a maximum 4 outstanding packets for which acknowledgement is not received. Maximum 4. Right? So this way, this is called as a pipeline. This is a pipeline mechanism in which I can receive or we can get a better utilization of the protocol. So this we will continue in the next class. that is tomorrow. So we have to use the range of sequence number. So definitely, as I gave the example, we need to increase the range of the sequence number. We cannot survive with just 0 and 1 if I want to improve the utilization. And packet buffering is also required at both the sides. So you see that, okay, after sending this packet, let us say 2, 3, 0, 1, these 4 packets have been sent. I need to buffer these packets until I have not received the acknowledgement at a sender side, right? Because after receiving the acknowledgement only, then I can remove this packet from my buffer. Otherwise, if the acknowledgement is, let us say, not received, or this packet is not received at the receiver, then I need to retransmit it, and without buffering I cannot retransmit it. So until the acknowledgement is not received, I need to keep the packet in buffer. For the stop and wait, I don't require any buffer. Receive the packet 0, and that's just one packet is there in my buffer, that's all. And once I acknowledgement received, then I can just take the next packet and then send the next packet. So buffering is required, and buffering will require at the sender and the receiver both sides. We'll see that. And range of sequence number will be required. So for these 2 basic approaches are there, and these 2 approaches are called as go back and approach, or you can say algorithms basically. So that is go back and the selective repeat. So these 2 we'll discuss in the next class. Okay, so these 2 are pipeline based protocol. So go back and selective repeat. So that we'll discuss in the next class. Okay. So that problem we'll take it up on the discussion forum. Okay, I will create one scenario, and meanwhile you can also recreate this scenario, and then we'll see that. Okay, well, sorry, which one? This one. Then we'll see that, okay, is there any ambiguity can occur in this protocol if the acknowledgement is delayed.